All right, welcome, ladies and gentlemen, to the lecture Deep Learning for Natural Language Processing in the year 2020, summer semester 2020. This year, we're gonna make, due to the current situation with COVID-19, Corona, we're gonna make videos of almost all of the lecture. So the first lecture is today, the kickoff. This lecture will be held by me, Steffen Eger, pictured here, and my PhD student Wei Xiao. And there will also be other tutors which I will be presenting later on. Um, Good. So we start with discussing administrative course issues. So after completing this lecture, you will be able to do many things. In particular, you will be able to deal with neural networks and deep learning. So these concepts are equivalent names, synonyms, so to speak, in a sense. So they are just different names of the same thing. You will also you will also be able to explain the concept of word embeddings. So what are word embeddings? These are vector representations of words, characters, or sentences. So real numbers that represent these linguistic concepts. You will be able to understand, describe neural network architectures that solve NLP problems. So that solve natural language processing problems, such as sentence classification and sequence tagging, and we're going to see some illustrations of these problems later on in this lecture today. Also, other tasks, NLP problems involved are, for example, machine translation, and you'll be able to do some really real implementations of neural network architectures for NLP problems. So the teaching material can all be found in Moodle, the lectures, the exercises, submissions. So go to Moodle and check them out there. So the resources that this lecture is based on is mostly based on NLP papers that are either very recent from 2019 or maybe now even 2020, but also we include a couple of classic papers like from 2014 to 2018. And the reason is that we use these papers instead of textbooks. And the reason is that deep learning is changing very, very quickly. So something that was used 2 years ago or 3 years ago, 2017, is already considered very old stuff. So we do not want to base that on a textbook written like a few years ago, because most of what would be in this textbook would be considered quite outdated by now. And the lecture, as you can hear, is held completely in English to address a wider audience. So there are additional resources that you may contact. For example, there is a Stanford lecture by Richard Socher, previously given by Richard Socher. Now it's given by other people, including Chris Manning, which you can find on YouTube. And this lecture will also be covered in our so-called inverted classroom lectures. So you will have to consult that video lecture anyway. But if you want, of course, you can also have a look at all of their videos they have. So they have much more stuff than we will actually cover in this course. There's also lectures from other people, from other communities, for example, Andrew Karpati. Feel free to look that up on YouTube. If you really want to have a look at the book, try out the book Deep Learning by some big guys like Ian Goodfellow and Joshua Benjua. Um, Feel free to take a look at that book if that helps you further. Um, Besides videos and books that you could consult, there are also papers that you would have to read or that you should read. And there are mandatory papers. So roughly for like 70 to 80% of the classes will have exactly one mandatory paper. This mandatory paper will be required to be known in the exam. So we might pose exam questions on the mandatory paper, so you'd have to know the contents of these papers, and they will also be relevant for the grading. So each week when we do the grading and the home exercises, you'll have to ask 1 or 2 questions from these mandatory papers. So these are really obligatory, and they are also very interesting reads and papers that have become very popular and impactful. So we really urge you to read them if deep learning in natural language processing interests you. There are also, of course, many optional papers that you could read. They are optional. I think you have enough stuff to do, but if the topic is so interesting, go ahead and read them. We'll usually list some papers at the end of the lectures. We can also give you additional literature if you want. Feel free to ask us. And yeah, if you cannot find a publication, also feel free to ask us, but this is a very unlikely situation. So there's the tutorial practice class. This will be held every Tuesday right after this lecture. So here it says a room, but we're probably most likely not going to have any room because also the the tutorial will be online, so there will be a video, and besides the video there may also be a Zoom conference. So this is not yet 100% figured out, but probably a video plus a Zoom conference where you can ask questions to the tutor, and you can interact directly with the tutor and with your peers, but we'll have to figure out that exactly, and we'll let you know via Moodle how that goes. And the exercises are very important, so go to the exercises because they give you a practical experience and hands-on training of what you've learned. So you will also learn to program, which we don't do in class. So programming is really the basis if you want to continue with this field of research. And with the exercises you can obtain a bonus which improves your final grade of this course, which I will talk about in the next class. And the practice class, it says here, it will be organized by Michael Bugert, but it will actually not be organized by Michael Bugert, but it will be organized by Wei Xiao, and it will be organized by Nirai Pandey, whom I will also introduce in some slides ahead. So what is the bonus system? So by participating in a practice class, you can get a bonus of 1/3 of a grade, or maybe even a full grade. We also have to figure that out if you can get a full grade. And the following rules, so we have here 5 rules. They are not yet 100% certain. We'll keep you updated on Moodle if anything changes. But the rough idea is you have to reach 70% of the points for the home exercises. So we have about 10 homeworks, each of which gives 10 points. You'll roughly have to have, or you'll have to have 70% of that. And you need to participate in a shared task, which will take place in the second half of the course. This shared task is, the scope of that shared task is that you have to compete with others. You have to compete with others on a common problem. So there will be a common NLP problem that we will give out, and this NLP problem will be some standard problem, but in this year like text classification or part of speech tagging. And in this year we almost with 100% certainty have the condition that we will probably work on a modification of that where you have to work with robust deep learning. Robust means here that there's an attack on the system, in the sense that somebody perturbs the input for the system. So the system has been trained on some data, and now it comes in new test data, and this test data has been modified in some malicious way maybe, and the goal of you would be still to design a robust system that can deal with such noise. But the details of that will be given out later in the lecture. So you have to pass the exam without the bonus. So the bonus cannot turn a 5 into a 4. The bonus can only be used in the exam in this semester, and it can only be used once per student. The share task. So you will work on, now here it says generating poetry, so that was last year. So I already talked about what you will most likely be doing this year. The cool thing about the share task is that you will work in groups of up to 3 people. So you have the option to work with other people. And not only do you have the option, but we really, really, really recommend you to work with other people, because if you work with other people, you can share knowledge, you will get better systems, and you will be prepared for the future, because both in industry and in academia, group work is more and more relevant. So we really require you work in groups, and it's also much more fun usually to work in a group. So you will develop a solution to the problem and then compete with others in the group. So last year the share task was graded, giving points. This year we're probably not going to make that graded. So probably the requirement will only be that you pass the share task, and that's all. So you have to submit running code, that's all. And there's also the option, which we still have to figure out, if you can get a bonus of up to a full point. And if you have that bonus, then additionally to handing in your code, which has to run and give a proper solution, in addition to that, you would have to write a short report, maybe up to 4 pages. And you'll have to give a presentation of your system in the final class. Tutorial and participation in the home exercises and performance in the final exam correlate, as shown here in this graph from one of the previous years. Here it shows like these are the points are student grades, and you see that those students who got higher scores on Moodle, so these are points they got for the exercises, also had a tendency to get a higher score on the exam. So increase your likelihood of getting a good score on the exam by participating in the tutorial. The programming framework will be Python NumPy, which you most certainly already know. Then new will be TensorFlow and Keras, which we will introduce in the tutorial. Our tutors, besides Wei Xiao, will be Nirai Pandey, pictured here, and Jan-Michael Bodensohn, pictured here. If you want to make an appointment with them, contact them via Moodle, or you can also, of course, make an online appointment. So you could meet with them via Skype or via Zoom, for example. The common practice is you study the slides in 24 hours before the exam, so at least some people do that. So this is not recommended at all. Instead, start learning for this class in every lecture and in every tutorial. Put yourself in the middle of the course. Discuss with others. Think beyond what we talk. Read some papers. Discuss with your classmates. Ask questions on Moodle or on the Zoom conferences. And the final exam. We will also announce the date on Moodle. You can then register via Toucan, so that will most likely be in August, so almost certainly be in August. The important thing will be the exam questions will be in German and English, and you may answer also in German or English. Even though it's possible that we change that a little bit this year, it's possible that, yeah, we'll have to think about that, because 2 of our tutors don't speak German, so we'll have to think about that. So it's possible that this will be made optional to be in English. The resources allowed is, first, the scope is the lecture, the mandatory readings, and the practice class. The grade will be given by the exam plus the bonus system. You may bring a dictionary if neither English nor German is your first language. You may most likely not be allowed to bring a calculator, because a calculator is not at all required, because there will be nothing to compute in 99% with 99% probability, and also nothing else is allowed. If you have questions, suggestions, post a Moodle in post a message in the forum. Otherwise, write an email. You'll find the email addresses of our tutors on Moodle, and ours, like Wei Xiao and mine, you can find on the internet. And if that doesn't help, yeah, as I said, write an email, not to Michael, but to Wei or me. So here's the syllabus. Here's the syllabus. Today we'll talk about history of deep learning and the history of natural language processing, like more the most recent history. And we will also introduce the first neural network architecture, so-called perceptrons. Next lecture we'll talk about machine learning background, so all the necessary machine learning background that you have to know for deep learning, such as splitting your data into train, dev, test, or which evaluation measures there are. Then we will go a little bit into mathematical background on how to train and learn a neural network. We'll introduce the backpropagation algorithm. After that, we have 3 lectures on word embeddings. So these are vector representations of words. First, we'll cover the classical model by Thomas Mikolov, SIBO, and Skipgram. Then we go into extensions of that in a bilingual or multilingual space, covering more than one language. We also look at syntactic extensions, and we'll look at the most recent innovations, which are called contextualized embeddings. And the model architectures in this context are called Elmo and Bird, and some of you may already know these. Then we look, instead of embedding only words, we will also look at embedding whole sentences. And in between these word embedding lectures, we have a lecture which is slightly more NLP, or slightly more linguistically, which is about dependency parser, how to parse sentences into a syntactic structure. But of course, deep learning can also be applied to solve this problem, but still the focus is more from the perspective of NLP. And we put this in between because the word embeddings part 2, in particular the syntactic embeddings, they require dependency parsing. So so this concludes the first part. So the first part is representations. Of the input in deep neural networks, plus background and plus mathematical background and computational background, and how to optimize these architectures and how to train these architectures in particular. And then in the second part of the course, we will talk about 3 very popular architectures for deep learning. The first one is called convolutional neural network, the second one is a recurrent neural network, and the third one is an encoder-decoder neural network. And I will outline all 3 of them later today in the lecture. Then we have a mock exam, Probeklausur, where basically there is no video lecture, there's no lecture at all, you just stay at home and you solve the Probeklausur. Then we'll talk about current trends, which will most likely involve our own work. Our own work that we have done in the last 2 to 3 years. And then in previous years we had guest lectures where PhD students were presenting something. This will probably not be included this year because there will be a public holiday during this time. And in the final lecture, we may do a summary, but most likely we just do this shared task award presentation. So those people who want to get a full bonus, they should present, and they will also get an award. So we will award the best participating systems. So there are some lectures underlined. So these are what we call inverted classroom lectures. In previous years, we had the regular lectures, which were like physical lectures in Darmstadt, And uh, as a variation on that, we had lectures where people did not have to physically come to Darmstadt, but they could watch a video at home. So this year, everything will be a video. So the basic meaning of the inverted classroom lectures is that a video will not be by us. So it will not be by me or one of the tutors, but it will be by people from Stanford. And the second difference is that this inverted classroom will then have a shortened lecture by ourselves, which will roughly be only 30 minutes. So we will do an additional video that may cover some other important things that we deem to be important, but this will only be 30 minutes, and the rest of the 1.5 hours will then be covered by the exercise. But the exercise then, of course, also is shorter than a typical exercise. And when we have the inverted classroom, there will be no separate exercise slot from 50 to 70. Instead, the inverted classroom will take place from 30 to 50. So it will take in the place in the time of the regular lecture. Important is that the inverted classroom video and our lecture overlap, but so there's certainly some big degree of overlap, but there will be things only covered in the video lecture, and there will be things only covered in our 30-minute video and in the tutorial. And for the exam, you have to know both of them. So you have to know the union of these two sets. So sometimes there's a complaint in previous years that the deep learning for NLP course takes too many resources from students. So people said, okay, it costs too much time, but basically that's not true, because we have an effort curve that in the beginning there's not much to be invested from your side. And as time progresses, when we start to have the shared task, then of course you have to do more, you have to invest more, but it's also fun, I would say, to work with other people in a group. But then in the end, we have the shared task summaries, we have the mock exam, we would have either a holiday, public holiday, or the guest lectures. So in the end, really the effort decreases quite considerably again. And I think even though it is a little bit that you really have to invest in this lecture, it's worth it. You will be prepared for the future, and overall it's still doable. In terms of skills that are required, so I listed 4 different types of skill: math, programming, linguistics, NLP. In terms of math, there's not too much. There are only 2 or 3 lectures where we do a little bit of math, 1 lecture where we do some proving, in one or 2 other lectures we do a little bit of derivatives, but it's really doable. And if you have an ordinary math background, that should be totally fine. In terms of programming, it's more. So if you want to pass the tutorial, you really have to do more programming, but also overall it is not too much, and regular computer science students should be able to do that. Linguistics. So what is linguistics? So this is the study of language. Well, we're gonna have a little bit of that, but overall not very much. Instead, more we're gonna be on the applied side, and we're gonna do natural language processing. So we are gonna solve tasks and problems such as: is this email a spam? Is this message a toxic comment on Facebook? So these are tasks that linguists would not ordinarily try to solve, but they are the main focus of our class.